All right, so now we've got our beaker. I want you to add this membrane in the middle, and then we'll put our water in. What I want you to do, though, is go ahead and just tear the water in half. And we'll start the water about 2/3 of the way up. Okay, so now we've got our beaker divided in half, and we can add our solutes. All right, so if you'll notice, we're getting more solutes on the left than the right. So take a minute and show me what you think osmosis would look like. Now we have our membrane, so we can do osmosis. All right, so remember, in osmosis, we're working under this presumption that with a membrane, the solutes cannot move across that membrane. And that's the case for most solutes because they're too big or complex. So what's going to happen? What's going to move instead? Hopefully you said the water. So what we want, again, is the same concentration of solute to water on both sides. So what we need to do is drop the water down on this side and bring the water up on this side. Now I put them in a row just so you can kind of really get that perspective of the same amount of space between them. But in real life, it would really be spread out more like that. So that's osmosis in a beaker. Now we're going to move over here to the cell. And the cell membrane is actually the outside or the membrane of the cell itself. So we're going to put a couple solutes inside. And we'll put the rest of the solutes outside. All right, so with osmosis, again, you can't move the solutes. So what's going to happen? What would we call this solution outside of the cell because of the number of solutes? We'd call that hypertonic. Okay. Therefore, in here, it would be hypotonic. So what's going to happen is water is going to move across the membrane, and it's going to move from the hypotonic to the hypertonic solution. So as water moves out of this cell is going to shrink. And I want you to go in your book, it's probably around page 102 or so, and look at the example they use of the red blood cell and how that happens. And remember, once we change the size and shape of a cell, often we alter its function and make it unable to do its job. So what happens to the osmotic pressure within the cell? If the water goes out and this shrinks, what happens to that osmotic pressure? Well, we'd say it drops. So again, look in your book so you can understand how that really affects red blood cells and other cells in the body.